Hello and welcome to another video. In this video we're going to be working on unique length-3 palindromic subsequences. And in this one you're given a string s and you want to return the number of unique palindromes of length 3 that are a subsequence of s. Note that if there's multiple ways to do this, it's still counted only once. Okay, and so a palindrome is a string that reads the same forward and backward, and a subsequence of a string is a new string generated from the original string with some characters deleted without changing the relative order. So ACE is a subsequence. So essentially subsequence, you just pick some characters and you delete some other ones. So in this first example, these are the 3 palindromes. So you have ABA, AAA, and ACA. And the second example, there's none. And in the third example, there's BBB, BCB, BAB, and ABA. Okay, and then the string is 10 to the 5th, and it's only lowercase English characters. So there's a few ways to do this, but I think a pretty intuitive way is we can just say, like, let's just imagine the character we're on is like the center of the palindrome. How many palindromes can we build? And so what do we need for a 3-length palindrome essentially? Well, if we have some character in the middle, we can just have a count of every character to the left and every character to the right, right? So we'll have 2 hash maps of like the count of like A, the count of B, the count of C, and whatever. And as long as the count in each of these of a character is at least 1, so if there's an A here and an A here, that's a palindrome. If there's a B and a B, palindrome, C and a C, and so on. So we can just say, like, for every character that we go through, we'll just build every possible palindrome. There's only 26, right? Because these hash maps of characters are only 26 and 26. So essentially for every character, we'll just say, like, okay, let's make that the center. And then let's just figure out how many are over here, how many are over here. And in order to get these dictionaries of characters on the left and the right, we can basically just start off looping through our array of characters, or the string, get a full count here. And then after we get the full count, as we're traversing, we're going to get, like, we're going to have 1 dictionary on the left and 1 on the right. So we're going to have 1 over here and then 1 over here. And as we traverse, we're going to move characters over. So let's go over one of these examples doing this essentially. Well, I guess let's just go over this one. So let's get rid of all this. Okay, so we're going to go through the string, get a count of every character. And the reason we need to get a count of every character is because as we're removing characters, we're going to need to know, like, are there any more left? So you can't just have like a set or something. So for this, there's 2 A's, 3 B's, or 4 B's, and 2 C's, or 1 C. Okay, and then we can actually write out this array, or this string as, so, oops, B, B, C, B, A, B, A. Okay, so this is our right count here, right? And then we'll have the left with nothing. Okay, so as we go through the character, we're going to remove it from the right, and then we're going to add it to the left afterwards, right? Because when we're on a character, this character is no longer on the right side, but it's not on the left yet because it's the character we're on. So we're going to remove a B from here. And this is our right, this is our left. So we can't make any palindromes here because we have nothing on our left. So we're going to go to the next character. And when we go to the next character, now this is in the left, so we're going to add a B here. Now we're going to remove from the right. And we're going to say, okay, for this character, how many do we have? So we have a B here and a B here, so we can make BBB. So we'll add that to the result. And our result can just be a set, so that way we don't have any duplicates. Okay? So then we're going to go here and move it from the right. And not add to the left yet. And how many characters can we make here? So we can make just CBB, that's it. So, okay, and then we're going to add it to the left. And then here, remove, what can we make here? So we can make BBB, but we already have that. So there's nothing else. And then we're going to add it to the left. So there should actually be 3 here already by now. Yeah. So 3, 4, yeah, this is right. Okay, so remove from the right. Not do anything yet. And then what can we build here? So this is basically, we can build BAB, right? Because it's the middle, so. And then now we add it to the left. So we have 1A. And then here we can build BBB, which is already in there, and we can also build ABA. And then, yeah, and then we're going to get rid of this guy and add it to the left. So and here we get rid of this last A, so we can't build anything. So these are the 4 we can build. So essentially, when we're on a character, remove it from the right. For every character to the left, check if it's in the right. If we can, we build left character plus current character plus the right character. And for every single character, this is basically 26 operations, so that'll be that should be able to pass. And this is really useful to make these hash maps of characters because this is going to be O1 space. So it might have like bad practical runtime in LeetCode or something, but theoretical time complexity and space will be really good. So yeah, that's what we're going to code. Okay. So we're going to make a result that's just going to be like a set. And the way to do that in Go is there are no sets, so you just make a hash map. And then you just make the key, and then the value can just be an empty struct because we don't really care about the value. Okay. Then the left side is we can use a set because we're going from the right and adding to the left. So the left can be a set. The right has to be a dictionary though. So left is just going to be the same thing. Make map. So left is just character. So this is just going to be byte, which is just character. And then the right is going to be a dictionary. Map byte, and then we need to count. Okay, so we're going to go through every character and increment the right ahead of time. So and we'll just say right of SI. Okay. And then now we're going to go traverse one more time. And now what we need to do here is we need to decrement the character and then do the loop. So we're going to go one more time here. Yeah. You can technically... No, actually it doesn't matter. Yeah, you can do like this if you want to because the last character can never be in the loop, but this is going to work as well. So the first thing we need to do is we need to get the character. So we can just say the character equals this. Then we need to decrement the right count of it. Then what we need to actually do is we need to actually delete characters from the right because we're going to say take every character from the left, and if it's in the right, then do this thing. So we need to actually delete if there are no more. So 0, we're just going to delete it. Okay. Now we're going to loop through every single character in the left, and you can just use a range for loop. So we can just say it like character, left character or something. So this will give us all the keys. So we basically need to check, does this exist in the right side? And the way to do this I showed before. So you basically, we don't really care about the value. We just care about if this key exists. So we can just have this, and this will give us left character. So if it exists, this OK will be true, and we don't really care about the value because we just want to know if it exists or not. So essentially we can pre-compute this, and then we can just check for, is this OK true? If it's true, then we're going to get the palindrome. So palindrome string left plus string of our current character plus string left again. So it's going to be the same character on both sides. And we can just add it to the result, and then because the result's basically a set, it'll not have any duplicates. So from, and then yeah, if you want to use a set, you basically initialize like this, so you just have an empty struct. Okay. And then we need to, after we're done with this character, we need to put it in the left, so we do the same kind of thing. So left character equals empty struct. This is basically just set. You can also make it like a Boolean dictionary or something if you want to. It doesn't really matter. Either one's fine. Yeah. And then after this loop, we're just going to say however many characters we have in the result, because this is basically a set of palindromes. That's what we want to return. So, and yeah, you can argue we did make this result, but this result is going to have like a finite length, I guess, because the middle character can only be 26, and then the outside character can only be 26. So this is like 500 something. So I will say this is O of 1. Like no matter how big the string is, it doesn't matter. You can only have this many total. And then yeah, and then these dictionaries are also O of 1, right? So this is O of 1. Yeah, O of 1, O of 1. All these are O of 1 because this is only 26 characters. 26 characters. This is 500. Okay, let's try to run it. Let's see if we get any errors. All right, let's see. Undefined left C. Now this needs to be left. Oops, left. All right. Let's see. Okay. Yeah, this might be slower in LeetCode. Like I think the other solution is faster. Yeah, so this one looks like it's slower. The other solution that I think works faster, but O is the same, is basically you can get the start and the end index of every single character, and then you can essentially just, for that, so like let's say an A starts here and ends here, you can take the entire substring in between them and turn them into a set, and that's the number of characters you can use as the middle. So you can do that as well. So for like A, you'll get the start and the end, you'll get this whole substring, and then this will be 3 characters, so that would give you 3 palindromes. For B, you get the start and the end, so there's nothing in between those. For C, there's nothing in between those, and so on. So that's the other solution that runs better on here, but as far as time complexity, this one's fine, and I feel like this one's more intuitive. This is the one I wanted to show. This is linear, and I would say space is one. Yeah, so that's going to be all for this one. Hopefully you liked it. If you did, please like the video and subscribe to the channel, and I will see you in the next one. Thanks for watching.